Let's see if this works. Hold on, I'm installing that all the time.
And we're live, yay. Okay. All right, so Git, source control. Stop emailing code to people.
Do you actually do that?
Yes.
Yeah. Or just stick it
I
in
am
Google
TA
Drive.
for a class that's
Drive.
mostly full of MEs, and that's how they exchange code.
I've used Google Drive as a source control before.
You really?
Yeah.
Why?
We were too lazy.
Why didn't you just set up a GitHub?
Another one is zipping up all the folder and then sending it to someone on Facebook Messenger.
Wait, who's done that?
One of my project members for my senior project. So now that we've talked about bad ways of control of managing your source code, let's talk about Git. So what we will be talking about today are some Git commits, some basic Git commands that you'll use in your everyday usage, what a branch is, the local Git repo versus a remote Git repo, rebasing and merging, and configuring Git to work better for you. All right. So the basic way that Git works is through something called a commit. It's where it takes a snapshot of your project at a certain point in time, what the file structure looks like, what is in each file, and what happened before it. So each commit has a parent, it has a set of info about what the project looked like when it was made, and a message about that the developer writes about what happened in that commit. The way that a commit works is you add files to what's called your stage area. So by default, files are untracked in Git repos. When you add them, then they become staged, and it will notice if they've been modified since the last commit. So if I open up my little Git thing over here, and I do oops, Rose-Hulman, Git talk. All right. So now we're in a folder that I made for this talk. You can find it at, let's see if I can, ada.csc.rose-hulman.edu, and then /pudocf/git talk. Let's see if I can. If you guys want to. So you open that up, you get this page, and you can see activity, some info on the repository, and a network of commits and branches. So here is a branch, here's a branch, here's a branch. The default branch in a repo is called master. And then you can create other names for branches as you go along. You can even change master to a different name if you so choose. Sometimes if you have a development branch, that will become your default. And then if you're working on something that is in where there's a production system involved, where you can have that production system track a production branch, so that whenever you have any changes, you just set that branch to just merge any changes into that branch, and it will save those or automatically deploy. So just a git commit. If I did something like so let's say I create a file called test.txt and I add, hi everyone. So then if I do something called get status, it will show that, let's bigger. Test.txt is an untracked file. I can go in here and do git add test.txt, and now status, it knows that there's a new file in the repo called test.txt. Then if I do a git commit, what it will do is any stage changes to be committed will be automatically added to as a commit that you can then look back through history of all of your commits, so that if you say, oh, I made a change two commits ago where I changed this variable to this variable, but I really needed this variable, so let's go back and grab that code. You can go back and see what you had in history, grab that piece of code, move it into your current file, and save your work and not have to redo all of it. So git commit -m added test.txt. You don't have to write exactly that. If you add a new feature, you can say work toward such and such feature. And then if I want to push origin master. Oh, wait. I forgot something. There we go. All right, so now there's added test.txt, and there's merging what was originally master into my new master. Because what happened here was I had made these two feature branches last night, and I merged those into master, and then merged that change into master again. So what this is called is a branch. They're normally used for if you're working collaboratively on a team, each person is doing their own task. They can each have their own branch, so that, well, one person makes a change in code somewhere in one part of the project, that doesn't affect someone else as they're doing their changes. So if someone is adding a completely new feature that breaks a lot of the code, well, if someone is working on a feature that doesn't interfere with that, but they can still use the old working code with their new feature. So they don't have the intersection that could cause issues. All right, so that was a little bit on git commits. So git clone, I'm just gonna go down this list with some of the fun commands. So git clone is how you're going to get a project. What you do is you do git clone and then a git URL. So that is the URL that the project is located at. If you go to something like GitHub, which is not Git, GitHub is a place to store your source code, not a they're a repo hoster, not a actual source control system. And I were to go to a project, let's go to still kicking. So this was a hackathon project for us. What you can do is get a URL right here, copy that, paste, do git clone URL. It will grab all of the code, pull it down to your machine so you can interact with it like it was a project on your computer. What you can also do with that is, because some repositories won't let people push code to their repositories online, you can fork it into your own account on GitHub or GitLab if you're using the local one to Rose-Hulman.
How did you get the Open Visual Studio option there? Because I don't have it on mine, and I have Visual Studio. Actually, I have Visual Studio. Yeah, how did you get that actually?
I don't know.
Okay.
I really don't know.
It's just it's something random.
So if you just copy that, put it into here, so git clone. Do not have the right thing copied. Also, don't really want to clone that one. So git clone URL. It will download a copy of the repo into your computer. And let's grab the RHA. Alright, because I have it. So I can just copy that. Git clone u enter going into git talk. So if I just cd into git talk, then I'm on the master branch of this, and if I do and I can do a git pull sure e.text. Yeah! And I can pull the branch from. So what I did here was a git pull, which will grab a branch from some remote repository. What this is called is the remote, and this is the branch. You have the same syntax for a git push. So push is sending code from your local machine to the remote. Pull is getting code from the remote to your local. Does that make sense? All right.
Can you describe what you do with git fetch?
Oh, git fetch will get any changes that it will kind of say, hey, do you have any changes that I don't have on my local? And but it won't pull the code and merge it with yours.
Pull more
So-
merges, right?
Yes. If you pull, you will typically, if there's code on the remote that you don't have, it will do a merge with your code. Which is how I wound up with the light blue branch in that network. All right. So checkout is a very nice command. Checkout is how you switch from one branch to another in Git. It can also be used to check out a certain file from the remote if you have made changes to it on your local. So you can say, okay, I recently made a change to this, but I just want the original version of this file. Just git checkout file name, it'll get that old file. So right now I'm on the master branch. If I wanted to change to the feature branch, all I have to do is git checkout feature b/text or b-text, and now I'm on that feature branch. And I can do anything with that branch. Like, let's say we're gonna make a file. Don't think I have a hideout text yet. All right. All right. So now I've just added the hideout text file to that branch, but then if I do checkout master, I don't have the hideout text file in that. But if I there it is. So checkout is something that's also able to create a branch if through a little sorcery. Using a -b flag will allow you to create a new branch and then switch to it. So if you make some changes, then realize, oh no, I need to be on a new branch to make these changes because I'm currently on master and I shouldn't be. What you can do is git checkout -b, new branch name, and then make your commit on that branch instead of on master, so that you can save your changes that way. So let's make a new branch for, I don't know, what should I do?
New branch.
Audience participation. You get a sticker if you participate.
New branch.
Branch new.
Newest of the branches.
What?
Newest branch.
What are you gonna put on the new branch?
That's
Goku.
wonderful.
Feature 2.
We'll go with that.
Yeah.
Here, take a sticker.
Oh yeah, I get a sticker.
Oh, where?
I didn't want to hit the camera.
I'll
the
grab
cute
one later.
one. I'm keeping as my new battle.
I'll grab one later.
I'll go into it later.
All right. So, let's try and get back on track. Now that we're on a new branch, we can change files, modify them in any way, and then we can make a commit, push the branch up to whatever source control host we're using, and then we can merge that into whatever branch, using whatever way we. All right. So let's make a commit on this branch, and then we can push that. Let's do, or we can just change this. Yay. So just changed a.text to have the first line be all lowercase a's instead of uppercase a's. And then commit. Yep. All right. And then, because we're using the local GitLab server, it's nice and tells me where I need to go in order to.
What exactly is ADA? Is that Ada or?
Ada is the local, or Rose-Hulman's GitLab server. So ada.csc.rose-hulman.edu, and you can just log in with your Rose-Hulman credentials. And we have a group name for, or group for Rose-Hulman hackers, and that has all of our projects that we've done in the past up there. So what I'm doing here is we made the feature 2 branch, and we pushed that up to Ada. And now what we want to do is create a merge request so that we can bring the changes we made in feature 2 into the master branch. What you'll normally do, so if you're ever working for a company that does a lot of computer science work, they'll normally have some workflow where you'll make a branch, do your work in that branch, and then normally do a merge request whenever you're done with your work to their master branch for the sake of project planning, ease of development, and multitude of reasons. So here, making a new merge request, source branch of feature 2, starter branch of master. And we've made a merge request. If it loads, which it might not, because the internet isn't working. So normally what they'll do is there is someone in QA that will go through, review your code. You might look, depending on how your team's structured, you might wind up doing that. And then you can go here, see the commits that are included in this, browse files. Okay, so in this one, I made this change. So what Git realized was, hey, this is the same line. It's just changed from being all caps to all lowercase. But these 2 lines didn't change. That's why this is better than email. With email, you say, all right, I've changed this portion of code. I changed this portion of code. You changed that portion. Where does all of this line up? Git handles it for you, makes it nice, easy. And with practice, it's second nature. Ish. Sometimes you forget to add something before committing. All right. So clone, you grab a repo, checkout, you can switch branches, you can get different versions of files, commit, make a snapshot of your repo at a time, fetch, get changes from the remote but don't merge them into your current branch, pull the changes from the remote into your branch, normally resulting in a merge, push, take the changes from your branch and send them up to the remote repository, and help is basically what type of parameters does this take? How can I use this more effectively?
Do you find yourself using fetch that often? Because most of the time I just use pull.
Normally,
Is that for me?
it depends on how you like to use it. All right, so a little bit on branching and merging with the help of a diagram. So branch is just a list of commits. And then it has a history, so you can say this commit is a parent of this commit, is a parent of this commit, and this is a parent of these two commits. Okay, so here we've got 3 commits, and the last one is master. So someone makes a branch off of that last commit called ISS53. And then they make their own changes, but then someone else goes from master and makes their own change because, say, there was an issue in the production environment where they had to make a hotfix commit to master while you were off doing your own stuff. Everyone on board still? Then they push their changes up to the repo. It becomes a new master as you continue on your work. So what's happening here, if you can see this, is what's going to be merged into master. This is what's being merged into, and then this is a common ancestor of the two. So what it does is it says, all right, I've got these changes, and these changes that have been made since this. So I'm going to find some way of putting those two together to make a new commit on top of those two that has the parents of this commit and this commit. And that is my merge commit. All right. So most commands in Git run locally. Your add, commit, help. But there are some that will interact with the remote. So a lot of the changes that you make in your repository won't get pushed up the upstream unless you use one of those commands. Basic ones are push, clone, fetch, and pull. Those all involve either getting or sending info to the remote. And then there are 2 ways that that the communication can be done, using something called SSH or HTML, or HTTPS. HTTPS is just going to be a basic username and password. But then SSH, you need to use a key to verify that your computer is what the host thinks that it is. So let's go to, see if I can open up GitHub. This might work. So we go to the project. If I go here, you can see SSH and HTTPS. So if you go to your profile settings on any of these sites, you'll be able to set up SSH keys at in some part of it, where you generate an SSH key on your computer that you want to access Git from, and then you register it with the repository hoster, and then it says, all right, whenever I see someone with this key, I know it's this person. And so you don't have to input a password or username and password every time that you are sending code up. When you use HTTPS, you normally will have to. So would you guys be interested in setting up SSH keys? Have you guys done so already? All right.
Can you have more than one key, or should you only have one?
You can have more than one key. You're going to have to create a key for every device that you use. So if you use GitHub or if you use your laptop to access a GitHub repo, you can use that same key for GitHub and GitLab. You might want to change it. It doesn't. It's up to you. Depends on how much work you have to do. You want to do. But then you also have like a MacBook that wants to connect to GitHub. Then you need to make a new SSH key on that to connect. All right. So this is a little bit different for each operating system, but normally it involves going to your home folder and then a folder called .ssh inside of that. Dot because it's a hidden folder, so you don't have to see it. So you might have the file already in there. Like if you do, and you do an ls in this folder, you'll see id_rsa.pub or something.pub. The default is .pub. But if not, you can do something like ssh. So do you guys all have the git bash open? You probably can use this.
Do now.
Hmm?
Do now.
So this is a tool, my tool. -t RSA is the type of security to use. Please correct me if I'm saying something wrong because I'm not 100% on this. -b is the number of bytes for the key to be. Enter, it'll create generate a key pair, ask you where you want to save the file. I'm going to put git talk, but you can also just leave it blank to use the default. You can enter a passphrase, and then it'll say, here's your passcode. then you can just grab that. Oh, I think that -C is supposed to be your email. It's been a long time since I made one of these, so I apologize. But you can just copy and paste this into the SSH port area in here. So you can just paste it in there, give it a title, add the key, and then it saves it. All right. So I don't believe we would have enough time to talk about something called rebasing. If you guys want, we can give a second talk on that or more advanced stuff. But if we were to do a talk that involved rebasing, we would be here all night. Rebasing is, depending on where you are, an alternative to merging. Instead of how merging just merges two commits into one, or into a new commit, what rebasing does is it will apply all of the changes on one branch to your branch. So if, say we had, let me shift the camera. Yeah, that's good. Commit 1, going to commit 2, commit 3, C4, so what it would do, is it would say, all right, I am on C5. I want to apply these two commits in history in the order that they happened. So it will say, all right, take this commit, and it happened before C3, so boom, right in there. And then take C6, it happened after this, so C2, then apply C3, C4, C5, C6. And it would apply each commit in the order that it happened. And then, so the changes from that happened in this commit would be applied, and the changes from this would be applied to the changes from that. And it would go all the way back. The issue with it is that if you're not paying attention, you'll get confused very easily, because what happens is it shows you when it's going through those, if there are any issues, it will show you it at this point. So if there was a merge conflict between here and here, you would see you would only see the changes from here. You wouldn't see any of these commits. So say you added 3 new methods in these commits. You wouldn't see those when you're looking at the changes from these, because they happen in the future as far as Git is concerned. So you need to be really careful while dealing with the rebase so that you don't get tripped up by that. Depending on where you go to work, if you are in the CS field, some people prefer to use it over a merge. It tends to be a matter of preference wherever you go. So, can you import? There we go. So now a little bit about configuring Git to make it nice for you. This one I have in a GitHub because I have not had time to change it over to So if I know that you guys have access to the presentation. We're going to be putting the presentation on somewhere so that it can be seen. Because the last page has a couple of useful links for continuing your research in Git. All right, so a git config is a file that you have in your home directory that makes Git a little bit nicer to use through the use of something called aliases and allowing you to have defaults for you. So what you can do with this is if you put this in your home directory of any computer, it will customize Git to your specifications across platforms. So say you like to have your default editor be Vim or Emacs. Don't know if you use Emacs, but and then it also lets you specify something called aliases. Aliases are a way of making Git do things that it wasn't already programmed to do. So say you keep doing git touch file instead of touch file. You can say, all right, if I do a git touch, just do a plain old touch. Do you know what a touch is? So touch is, if you touch file name, it will create that file. Simple. So you can do something called, or make something called git this. So you say in a folder, git this. It does a git init, git add everything, and then git commit, initial commit. My favorite is something called git fire. So what it does is it will add everything, make a commit, and then publish that commit. So if there ever is a fire in your office, commit, push, here, get out of the building. You can also do stuff like delete any branches that are already merged, find the branch name of the branch you're on, undo a commit, reset. That's something I didn't touch on. So there are 3 types of resets in Git. There's a git reset soft, a git reset hard, and a git reset mixed. Git reset hard is what you'll probably be using most of the time. It's where, all right, I have a commit that I know I want to go back to. All of the code that I've done this past time since that commit is just garbage and I don't want to keep any of it. Git reset -- hard wipes it all away. Clean slate. If you do a git reset -- soft, what it will do is it will just unstage any of those changes that you have made since that last commit. So if you accidentally stage something and you don't want it on there anymore, just git reset -- soft and it will let you do that. That's also something you can look up in the Git book that they have online for free. Very useful. And something that's also very useful to have in your Git config is autocorrect. If you mistype something like, let's see, I shouldn't have changed. So git, so I did git stem, it said, okay, it looks like you were trying to type this. And then after a certain amount of time, it will automatically run that command. So by default, it's disabled, but if you want to use it, just add into your git config help autocorrect equals, and then so what that is it's divide by 10 in that number of seconds. So that's autocorrect in 1.2 seconds. What you can also do with it is add some stuff for garbage collection. I just have it so that it doesn't do any, because that way if you have a detached commit, then you don't lose it. Doesn't normally happen. Guess that's something more for the advanced talk. Sorry. So this one I have on GitHub. This is my personal one that I use. So if you guys want, it's on the last slide, along with some other helpful links. So first one is Git's book. They have their own book. It is very useful. It talks about all the commits, including some of the ones that are called, or there are two different types of things you can do in two different types of commands in Git. There are Git plumbing and Git porcelain commands. Most of the ones we've talked about are the porcelain commands. They're easy to use, easy to remember, and you're not dealing with stuff called SHAs, which are how Git remembers all the commits. Plumbing will get more into the nitty-gritty of Git, how it actually stores the files, where it stores them, and you can see all of that info with here. Git internals. Yay. I just minimized my presentation. Then there's also one of the professors here has a course on Git. His name is Buffalo. He's awesome. His class is good. It's 1 credit hour. It's easy. Well, not easy, but it's a 1 credit hour class. Sample git config, that one's mine. There are a couple other ones on GitHub you can find. Steal their aliases because they'll make your life easier. SKCD has a explain on Git. It has some information, some useful information on it. And it has the picture that I had earlier. And then GitHub has their own cheat sheet with a bunch of information like the usual commands you'll be using. So you can go print this out, stick it on your desk, have it whenever you need it. Has stuff like reset, diff, what a commit is, what a branch is, how to initialize a repository, updating, and a couple other useful things. All right, this is by no means a full, in-depth, wide gambit spread of information on Git, but it is a good place to start for beginners. If you have any more questions, feel free to speak up now or send me an email later. And hope that this proved a somewhat useful way of spending your Thursday night.